All right, guys, in this video, we're going to go over really a continuation of some of the stuff we did in our notes number 25 video on graphing polynomial functions. We're going to throw in, excuse me, a couple of curveballs in terms of they're giving us the functions in standard form, like you see in this letter A. So we're going to do some factoring here to get in factored form to help us find those x-intercepts or roots. And then ultimately, we're going to finish off by talking about how to write some of these polynomials, depending on the information given, whether that's the graph or whether that is just the roots. Okay, so let's start with this first one. We'll do the stuff that we did from our last video on number 25. And when I look at this, I'm focused on looking at the degree and then looking for the leading coefficient right here at the front. All right, so my degree is 3, which is odd, and my leading coefficient is -1, which is negative. So when I do my end behavior, right, when I'm thinking odd, it's going to be opposite direction. A negative leading coefficient means I'm going to start at the top right, top left, and go to the bottom right. All right. I also want to make sure that we understand how to write this as x approaches negative infinity. The function is approaching infinity. And as x approaches positive infinity, so as you move to the right forever, the function approaches negative infinity. All right, we'll work on that in class. Okay, to find the y-intercept, I'm going to plug in 0 for x, and I'm just going to use this standard form that they gave us. Should actually be pretty straightforward when it's given to you in standard form. You'll notice that everything becomes 0 except for that 16. So your y-intercept is going to be 0, 16. All right, and actually we can graph that on this grid. Now let's do some factoring, okay? So I'm going to just copy down what I have, which is the opposite of x cubed minus 4x squared plus 4x plus 16. You've got options here when you go to the factoring. It depends on how your brain sees it. If you wanted to right now, you could go ahead and factor out this negative that's at the very front and then make everything else become the opposite sign. You could also leave it alone and just do your factor by grouping. I don't really care. It shouldn't matter. So I'm going to go into the factor by grouping right away, and I'll leave that negative alone for now. So in terms of what can I take out of negative x cubed minus 4x squared, I can take out negative x squared, which leaves me as x minus, I guess it's going to be plus 4. All right, what can I take out of the 4x and 16? I can take out a positive 4, which leaves x plus 4. Just remember when you're doing the factoring by grouping, always check if these are not the same, then something is wrong. Either you cannot factor by grouping or you've made a mistake. So I'm going to put the negative x squared and the positive 4 into one factor, and then x plus 4 is the one they share, so bring it down. I'm going to keep going because I want to take this negative out. So move it out, move it out to the front, not the x. Move the negative out, and you're left with x squared minus 4. And then you should notice that is the difference of two squares. So this fully factors as the opposite of the factors of x minus 2, x plus 2, and x plus 4. So this is my factored form. That's also going to allow us to find the x-intercepts, because remember, I'm always looking to see what makes each of these become 0, and that would be my x-intercepts. So in order from least to greatest is -4, 0, -2, 0, and finally 2, 0. All right, all of these are going to be multiplicity of 1 or single roots, so they're all going to be the same. And in terms of how they interact with the x-axis, they're all just going to cross through. So you're kind of your basic interaction here. Okay, so now we're ready to sketch it. Now I will say, and you don't have to do this in terms of like on our quizzes and tests, but I'm going to use Desmos to help me get some of the points that are kind of missing here. It doesn't always work out like this. You'll see if you keep trying it with Desmos after you find all this stuff. Notice I'm not using Desmos right away. I'm doing it to help me fill in any missing gaps. You'll notice it doesn't always fill them in, right? It just might not have any. So putting my y-intercept on, 0, 16, putting these three x-intercepts of -4, -2, and 2, all right? I know what my end behavior is going to be, right? Referencing that to the left. All right, so I know I'm going to be starting, way up here, and I'm going to be ending way down here, okay? But if I show you when I type this into Desmos, okay, looking at this table here, I know there's two tables, the one that's red, you can see that I actually have -5, 21, so just barely off of my grid. And then I do have -3, -5 is a point that I can plot. So I'm going to plot that here. All right. And then going back to Desmos, I have -1, 9. So -1, +9. And then back to Desmos, I have my last one I can do, which is 1, 15. Now, like I said, this will not always be the case in terms of points that you can help with, but ultimately, I always type it into Desmos just to see. In this case, I was able to find some more points to help me graph. I'm not concerned about this. If if you don't do that, it's okay. Like if you go a little bit farther than -5 here on that relative minimum value, it is okay. We will get to that later on in the semester. All right, so just making the rest of my curve so it looks like my end behavior. And there we go. There is the function graphed. Okay, so that's kind of the whole process. The only things that are really different from the last lesson, number 25, is you had to do some factoring. Everything else is pretty much the same. Okay, let's do B. All right, so B, first thing I'm going to do is write down my degree, which is 4. That's an even degree. The leading coefficient is -1. Writing here that is negative. So my end behavior, if I were to graph that, is going to be, they're going the same direction because of the even degree, and it's a negative leading coefficient, so they're both going to open down. So I'm going to write as x approaches -infinity. So as I move to the left, my function is going to approach -infinity, so go down forever. And as I move to the right in my x direction, my function will also be going down forever. Plugging in 0 into this standard form function will give me the y-intercept. And you'll notice that every single term here has the variable x. So everything is just going to become 0. So my y-intercept is going to be 0, 0. All right. Now into factoring, and I'm going to copy this real quick so I can factor it. The first thing I notice in terms of a GCF is all three of these terms have x squared. So I'm going to factor out the x squared. And honestly, to make this easier on myself, I'm going to factor out the negative as well. All right, so I'm going to factor out the negative to leave me with x squared minus 6x plus 9. Always go back and check to make sure if you were to distribute that GCF back in, would you return to the original? So confirming with my brain right now, we would get the same thing, okay? So I'm just going to ignore this negative x squared for a second and just focus on the x squared minus 6x plus 9. All right, so if you need to make the little x, the a times c that adds to b, you would have 1 times 9, which is 9, that adds to -6, and the factors for that are -3 and -3. This is a perfect square trinomial, which is going to be x minus 3 squared. Okay, so this is the factored form of that original function in part B. All right, so we have two zeros here. We already know 0, 0 is the y-intercept, also an x-intercept, and the other one is going to be 3, 0. Both of these are raised to a power of 2, so they're going to be called double roots, or they have even multiplicity. So I'll put even here, and they're both double roots. And in terms of what happens when we sketch it in terms of the x-axis, these are the ones that are going to bounce or touch, right? They don't cross the x-axis. Okay, so I'm going to go ahead and start sketching this. I have 0, 0, which is an x-intercept and a y-intercept, and 3, 0. All right, and I know in terms of my end behavior, I'm going to be going down forever and down forever. Okay, now I went to Desmos and I typed this in, so I'm going to get that for you here in a second. So here's this one. Let this go away. There we go. Okay, scroll here so you can see the table. And you should notice -1, -16 is something that I can graph. So I'm going to graph -1, -16. All right, but I will be going off the grid for the rest of it. And then I can also graph 1, -4, and 2, -4. So 1, -4, and 2, -4. All right, again, I'm not that concerned if you don't do exactly like where this dip, where this relative minimum happens. It looks like it's happening just before 2 there. And then I can also graph 4, -16, which is here. All right, so going ahead to make my rest of my sketch. All right, we are going to go to this first x-intercept. Remember, it's just going to touch, right? We're not going to go through, so I'm going to touch, all right, and bounce back here. All right, and I'm going to touch again, and then head back down forever. Okay, and that is it for this one here. Okay, now during class, you're going to see some of these sticky notes. They're not actually sticky notes, right? But they're a moment for you to pause, and I'll pause in our lesson in class to make sure you know how these are different from the problems we did in our previous lesson. All right, now this is definitely new stuff that we haven't done yet. So now we're going to kind of go the other direction. So instead of being given the function and we have to find all the characteristics and graph it, we're now given the graph and we're given some x-intercepts, a y-intercept, and we are going to figure out, okay, what is this function written in standard form, okay, or written in factored form. So in this case, we're going to just put it in factored form, and if I asked you to do standard form, you would just have to distribute everything, okay? So the first thing I would say for this is let's kind of go with the degree and leading coefficient based on the graph. So based on the graph in terms of the degree, I already know it's going to be odd. When I look at my end behavior, they're going opposite directions. And based on this being bottom left to top right, my leading coefficient is going to be positive, okay? Then when I look at how my x-intercepts are being, in terms of interactions, you can see on all of these x-intercepts, we're just crossing through. So these are all single roots, have a multiplicity of 1. So this degree is going to be 3. All right, so I'm going to write down my x-intercepts of -2, 0. I have -1.50. You can also write -3/2, that's fine. And then 1, 0. And they all have multiplicity of 1, right? They're single roots, and they're all just crossing through. Okay, so once you fill this out, and I know I haven't filled out the y-intercept, which I'll do here in a moment, but once we have all this filled out, we can go ahead and write kind of the general form in terms of using those x-intercepts to write factors. So my y-intercept is 0, -6. Now here's probably the trickiest part. You'll notice when you do this that you have subtraction with x minus these roots, all right? So I'm going to write down f of x equals, put an a, right? Because we don't know what a is yet. That is going to be our leading coefficient. We know it's positive, just don't know what it is yet, times, and then I'm going to always think opposite when I write down these factors. So x plus 2 times x plus 3/2, or you can write plus 1.5, and then x minus 1, right? Thinking opposite. All right, so this right here is what I need to see first. Then we're going to use the y-intercept, right? That y-intercept of 0, -6 to plug in to find a. All right, so basically when x is 0, your y value is -6. So I'm going to replace f of x with -6, leave the a alone, and plug in 0 for x. A lot of times on these questions, guys, they're going to give you this y-intercept to do this part of the problem, but it doesn't have to be the y-intercept. It could have been another point. Maybe this point -1, -2 is on there. I don't know, right? I'm not just going to assume. But just because if you see a question where they don't give you the y-intercept, they give you another point, like in this case, -1, -2, that's fine. You can use that point too. Okay, so I have 0 plus 2 is 2. This is going to be 3/2. This is going to be -1. Then -6 equals a times 3/2 times 2. The 2 is going to cross out. That's 3 times -1 is -3. So a, again, is going to be a positive. -6 divided by -3 is +2. All right? So when I write down my answer up here at the top, I'm going to write f of x equals 2 times x plus 2 times x plus 3/2 times x minus 1. All right, and that's kind of the general way that you're going to do these questions where it asks you to write the polynomial. Okay, let's do another one. Okay, so degree-wise, I see that they're going the same direction, right? The end behavior both going down. That's an even degree. And if I were to count, when I look at these, this one right here, -2, 0, is bouncing or touching. That's a double root. Multiplicity is even. The next x-intercepts at 1, 0, and 3, 0 both look to be single roots or just crossing through. So 2 plus 1 plus 1 is going to be a degree of 4. Leading coefficient is going to be, I don't know yet. Oh, let me put this back in here. I'm sorry. Leading coefficient was 2. I don't know what it is, but I know they're both opening down, so it's going to be a negative number. All right, the y-intercept is 0, -12. All right, so let's put on the x-intercepts. So I have -2, 0, 1, 0, and 3, 0. Now, like I said, the -2, 0 has even multiplicity, right? It is a double root. So this is the one that's going to be the bounces or touches when it comes in contact with the x-axis. The next ones are multiplicity of 1 or single roots. They're just going to cross through. Okay. Now, like we did before, I'm going to write down this function with a, since I don't know the leading coefficient yet, times, and I'm going to write my factors, but make sure to think opposite. So x plus 2, x minus 1, and x minus 3. Now here's where it can get a little tricky. Go back to your multiplicity, or go back to your graph. Whenever you have a multiplicity that's not 1, you need to have a power after that factor. So this one here, which is an even multiplicity or a double root, that one is going to be raised to the second power. Okay, so just keep that in mind when you're doing these, is that just ask yourself, okay, do any of these factors need to be raised to a power? And that one does, okay? All right, plugging in my y-intercept, I'm going to plug in -12 for f of x, right? That's my y. Leave a, and x becomes 0. All right, so that's going to be a times 0 plus 2 is 2. 2 squared is 4. That's -1. That's -3. This is -12. So I have -12 equals 4 times -1 times -3. That's going to be a positive 12a. And so a, if I move that 12 over with division, is going to be -1. And that checks out because we said that our leading coefficient was going to be negative. All right, so writing down my answer, I have f of x equals the opposite of x plus 2 squared times x minus 1 times x minus 3. Now, if you wanted to, you could write your a as -1. It's not wrong to put that -1, but I'm just going to write the negative symbol. All right, and like you saw on the previous page, there's another sticky note there to jot down some kind of summarizer of what you need to write the equation in factored form. All right, last page. So this last page is just more practice on writing down your factored form of a polynomial if you're given these zeros or roots or x-intercepts. The only thing that you have to be aware of, maybe not the only thing, but one of the things that can confuse students is you'll see when we do letter B and letter C that if you have irrational or imaginary roots or imaginary zeros, the conjugate is also going to be a root or a zero. Okay, so when we get to B and C, I'll try to explain that better. So here in part A, I'm just going to write down f of x equals, I'm going to put A, I don't know what it is, and then x plus 3, right, thinking opposite, x plus 1/2, and x minus 2. And that's where I'm going to stop. There's no way that I can find A. And sometimes in class, I might tell you, hey, we're just going to assume that A is positive 1. And so I might ask you to just write like this, where we just assume that A is positive 1. So again, I'll make sure you know when you're doing these for practice or for quizzes or anything like that, that you know when you're trying to find A or when I tell you, you know, just assume that A is positive 1. All right. Now let's do B. All right. 4 is just like the roots that we had in the first one, but this opposite of the square root of 7 is not. So I'm going to write x minus 4, and I'm going to write x plus the square root of 7, right? Thinking opposite. But the square root of 7, or the opposite of the square root of 7, is an irrational number, right? Irrational means that it's a decimal that goes on forever with no pattern, right? Like the square root of 7. So I need to also write x minus the square root of 7, because this means the square root of 7 is also one of our zeros or roots, right? That's the conjugate of the opposite of the square root of 7. And I'll make sure that we go over that a ton in class so you know to include that. I went ahead and assumed that A is 1. All right, and last one here, same thing. I'm going to write x minus 5 for that first one. I'm going to write x minus 6i, but because 6i is one of my solutions or zeros or roots, the conjugate of that is negative 6i, right, from our first semester work. So I'm also going to write x plus 6i. All right. Now, if you wanted to go, farther with this, you could write x squared minus 7. All right. Like in this part B, you could write that instead of writing these two. Instead of stopping here, you could keep going. And I'll make sure to clarify for you if I want you to keep going or not. Same thing here. You could write x squared, and this would end up being plus 36, right? If you were to multiply those together. All right, I'll make sure that when you guys do this on a Quizlite or a quiz or a test, if I want you to write it in fully factored or if I want you to multiply them together. Okay? All right, so that's it. Check out the homework. Come see me if you have any questions. Good luck.